I'm Kyle Okamoro. Thank you. I see we've really hit the diversity quota in this audience here today, so rock on, awesome. I see one female in here. We got to do a better job at that as an industry here, people. So I run the network over at Verizon Digital Media Services, which besides being the worst acronym in the industry, VDMS, it's a digital media company that got bought and put together by Verizon, and we provide services. So they're very, very creative, and they came up with Verizon Digital Media Services. We have taken a few companies together in the past. Edgecast Networks is the content delivery network, which I'll obviously be talking about today at the Content Delivery Summit. And we also bought a company called Uplink and Volacon, and took the Intel OnQ assets and some of the Yahoo video assets and some of the AOL video assets, and we put them all together to provide basically the cliche of the day, right, is end-to-end digital media services. We define the ends differently within the industry, so everybody can say they have an end-to-end solution. So our ends are, we take the content from the content creator, and then the other end is the consumer device. So pretty much everything in between, right? Some content acquisition, signal, encode, uplinks, transcoding, DRM, ad insertion, delivery, transmuxing, reporting, analytics. Those are kind of our ecosystems. I'm going to talk to you today about specifically the Edgecast Network, which is the content delivery network that we bought in 2013. And we're going to go into how that's really adapted and changed over the last 4 years, 4.5 years almost. And how video has just completely dominated our ecosystem, no real surprise there. And how we've started to really capture these mobile-first markets, these developing nations that just decided to skip the whole modem, dial-up, cable, et cetera, and just go straight to the phones. So how we've had to kind of change and adapt our infrastructure as a result of that. And then I'm going to talk about some software-defined networking and some traffic management on top of that network, and how that architecture has really helped us kick some butt in the market. So I think everybody gets the marketecture slides. This is a marketing slide that everybody's seen, I'm sure. But basically, the internet is growing. I don't think that's really too far of a foreign approach. But what's really interesting here is that there's still a lot left. In terms of the world consumption and the world penetration, there's still a lot. So 7 years ago at these summits and 4 years ago, we all talked about this hockey stick that's coming. We're in the stick, man. We're in the blade right now, and there's no end in sight for sure. Video is over 75% of our network today, and that's a lot of terabits. Obviously, video's a lot larger than websites and e-commerce platforms, so it's definitely the dominant gorilla. And what we find really interesting is that the growth rates that we're seeing, even in North America with 20 million more, is staggering, even though that's the slowest growing nation. But Asia, Middle East, and Africa are just screaming right now. And a lot of those countries are mobile first, or mobile only in some cases. So we've had to really adapt. And so I'll go into some of that. So I pulled up some old maps. Sorry, I do my own slides, so the font stinks. But this is an old map about maybe 2.25, 2.5 years ago. And we were really proud of this network. 8 terabits and 45 locations, 5 continents. And we had over 1,000 different unique networks that we were privately connected to. And we're like, wow, this is so big. How can we ever do more than that? And we had all the major football or American football cities at this point. We were really happy to have our first pop in Sao Paulo in Latin America, and that was just a very small pop, and it was growing. And it just kind of got crazy after that. And the marketecture team, or the marketing team, sorry, they hate us because we can't keep the map updated on the website. As soon as they publish a new push to the website, we add another dot, or we add another couple terabits, or we add another major market. And so this is the map as of I think I did this 2 weeks ago, and we already, sure enough, hit 49 terabits yesterday. It's crazy, and Mexico City is now launched as well. So like I said, they can't keep up, and I apologize for an out-of-date slide, but it's always out of date. You'll notice, I'll go back, you'll notice a massive push into the South American region and the Middle East region, India, and Southeast Asia. But we're still putting dots on the map in North America and Europe just because the growth is obviously crazy there and the traffic is very large and we're always trying to get better. But these developing countries, I don't want to call them second world countries, but these developing countries are driving the growth right now for us, and we're seeing that. And we can't just do the same thing that we did in Chicago, in Muscat, or in Santiago in Chile, for example, and I'll get into a little bit of why that is. So we've had to really adapt. We had a very clean architecture before where we had a router, top-of-rack switches, and servers, and that was it. And we just cut and paste and cut and paste and do the same thing everywhere. It made being a NetOps guy very easy, but unfortunately that day is long gone. So I talked about that. We had these concepts of a core router and top-of-rack switches. This is a very traditional networking architecture slide where the core router has all the switches coming in the back and all the transit and internet exchanges and peering connections coming out the front, going to some patch panel meet me room, and that was it. And each of these POPs were in their own right damn good, and they served us very well. Take a market like Chicago, we might have 2 of them, right, horizontally scaling out as traffic gets big, because there's only a certain amount of uplinks on a router. And it was great. It was wonderful. If we lost POP 1 in this lovely diagram, no big deal. POP 2 picked up the traffic, or POP 3 or 4 or 5. You know, if a market like Boston went down for a few hours, it wasn't really that big of a deal. The customers and consumers didn't even notice. New York picked up the traffic and other places, and life was good. Now, if a market goes down and we lose a router in a single kind of point of failure architecture like this, we start to swing 5, 6, 7, 8, 9, 10 terabits around in a region, and customers don't like that. And my chief architect said to me the other day, customer complaints are usually because of capacity constraints and usually leads to revenue vacates. It didn't really rhyme, but the point was there that we just couldn't do that anymore. And we saw the edge of the cliff, right? And we were racing toward it as fast as we possibly could, because that's all we knew. We just knew it was all about velocity. How fast can you grow? How fast can you take share? And how fast can you get more customers and more traffic? So we saw this, and we said, okay, while the team is racing toward the cliff, let's start building a bridge to get to that next plateau. So we completely redesigned it. We call it our next-gen network architecture. Again, I'm not a marketing person. It was not the best name. Very long to type out. So we've obviously abbreviated it to NGN, but that's okay. What it is this is a market now, an individual city, like Boston or Philly or Atlanta or something, and we'll have 2 border routers where all the connections happen in a redundant manner, or at least in a load balancing manner, if there's only 2, for example, to the internet exchanges, which we're a huge supporter of, the peering community, and the transit providers. And that's it. That's all they do. They're just out at the edge, right? They're at the border. Some call this a spine leaf architecture. And then the core routers have the bays of platforms and servers, whether we have our content acceleration platforms, our e-commerce platforms, our large and small object platforms to do video HTTP, our DNS platforms, storage platforms, whatever you want to put behind them. They're just an individual platform hanging off of these core routers. And we try to spread them out as much as possible. And then there's a mesh network in between of 100 by 100 or 300 by 100, depending on how big the market needs to get. That way, if we take down a border router for a maintenance or, God forbid, an emergency outage or a power failure or what have you, earthquake, et cetera, the other border router can easily take the traffic to the providers, keep the traffic in the local market. The core routers are still good, all the servers are still cranking, and we have 0 service degradation. It's not an entirely novel concept, but when you do this at that 50 terabit kind of scale, it gets a little bit more challenging. But what was really cool about doing this architecture was we actually eliminated things. As you kind of grow and scale and get more capacity, some might lead toward more complex. We actually simplified that quite a bit with this architecture. We eliminated the top-of-rack switches. We eliminated certain points of failure in the network. And now not only our data center has redundancy, but our network has redundancy, our servers have redundancy, the application obviously has redundancy. So it was a lot better for us, for our customers. So the big lift here was going from 10 gig to 100 gig, obviously. So we took that opportunity to just completely redesign the network. A lot of people just change out the router, change out the switch, change out the line cards, et cetera. We decided to use this opportunity to completely go over. Like I said, we've doubled every year for years now. We expect to double again this year. It gets harder and harder to keep doubling, obviously. I think that's a pretty understandable concept, but this has really enabled us to do that. So not only vertically scaling within a market, but also horizontally scaling within that market. So you can have 10 pops instead of one just massive monolithic pop there. Obviously, the redundancy was huge. We had a single router for years and years and years, and in some markets we still do. In some of these more remote markets where the pop is doing 10, 15, 20, 30 gigs. But in markets, Chicago, London, Singapore, et cetera, that just wasn't an option. If we lost our London router in the old days and it had 10 terabits on it, that was a lot of traffic to swing across the European continent there. So obviously reliability is super paramount in today's video age. Consumers are rightfully picky and demand a good experience that they should get. So that was a definite benefit of moving to this architecture. It also enabled us to decide when we had outages rather than outages telling us when we had outages. So we could proactively take outages and do maintenances and updates and refreshes and things that we call heart surgeries, where we take servers and production traffic while production traffic is going through a POP, actually do upgrades and maintenance on it, which some might say is crazy and stupid. But when you have a network redundancy and failover model with software defined on top of it, you can take some of those risks and do some of those things in real time when a customer decides to drop 15, 20 terabits on you without giving you a heads up. And then obviously availability, just always being there is super important, but I would say that's trivial if you're not always there with good quality. So always being able to deliver those high def bit rates that the consumers want. Always never being the bottleneck in the supply chain. I always want the phone to be the bottleneck or the cell site, unless it's Verizon Wireless, and then that never happens, I've heard. Or the ISP, unless it's Fios. Or the consumer deciding to throttle down their bandwidth because they don't want to pay. Those are all fine bottlenecks. I never want the actual content delivery network or my ISP connections to that specific user to be the bottleneck there. Okay, so I mentioned some of these harder markets. These are real life pictures from our DC ops crews that go around the world doing this. The yellow car is what one of my guys took to get to the data center every day, and there may or may not be a couple $100,000 worth of equipment in the backseat with him in some of these markets. These are, so Edgecast is our original CDN name. These are our Edgecats. They lived in our boxes for a few days, and they may or may not be in the office today, smuggled back from the country, probably not legally either. But these are the kinds of environments that you have to deal with when you go into these remote places that don't have an Equinix in the site with lots of cool redundancy and lots of space and power available. You're trying to shoehorn your CDN into these cable landing stations or into these telco central offices or these mobile switching centers, and very soon, in 2 years, we're going to be talking about how to do this in 50,000 mech sites, right? So what did we have to do? We had to react and adapt as much as we could. And it was super important to understand the local network topology before going in there with saying, here's our design. So we did a lot of questions and fact-finding. And we learned that in a lot of these markets, the networks don't like each other, and they don't really talk to each other. The US is a different model than that, where there's a lot of good peering now in between them, Verizon included as a good peer. Power availability is awful. They tell you that they have this power there, and then they don't, or the power's there for a few hours out of the day, or every time during peak hour, you see massive power losses. So all of these different things feed into how we have to redesign and re-architect the platform. A place like India, we see sometimes dozens of fiber cuts in a day, and the timeline on owning and operating dark fiber and trying to get it fixed is not an easy thing, especially as a non-Indian company. So that's definitely a challenge I don't recommend anybody trying to do. The politics is crazy. Trying to get gear in and out of Argentina, for example, is a challenge. So all of these things feed into how we end up with this end state where we have to get a nice pretty rack with lots of green blinking lights. So we end up working a lot with the local providers, right? The government agencies, the regulation agencies, the telcos, the data center providers, et cetera, and we work with them to design a platform that works with them. So rather than just saying, here's our architecture, here's our power needs, here's our weight limitations, et cetera. In Quito, for example, we were racking in Ecuador, and they brought out some silicone caulk, and they said, here, use this silicone to glue the data center floor supports. We're like, oh, you don't want to bolt these into the concrete? You guys just had a really huge earthquake here. You sure? No, this is what we use all the time, and the cabinet panels are just bending, like a U, as we put, a couple thousand pounds on them. So in a lot of those places, you have to get really creative because your customers don't care about any of that, right? They just want to be able to watch cool stuff. So I skipped a slide. So originally, we started out with this monolithic, super easy to operate, copy and paste network, which we called, one router and top of rack switch, because we're very creative. And then we said, look, some of these markets need to go big, right? So we need to go from super pops to mega pops. And we implemented the border core method with full mesh. We got rid of the top of racks, and we started to do these, 20, 40 cab deploys. But then, obviously, that doesn't work in some of these developing countries, so we decided to design mini pops with these guys. Sometimes there's a router, sometimes there's not, depending on the network that we're working with. And these could be 2 to 4 cabs, or even a micro pop, which could be just a switch with some servers hanging off of them, maybe 5, 6, 7, 8, 9, 10 servers. And when you do that, your cache footprint changes, your caching algorithms have to change, your hot filing has to change. There's so many different things that go into the software stack to be able to support that. While still getting a good cache hit ratio for good performance. So not only did we change the architecture, but we changed the software on top of it. From an engineering perspective and an architecture perspective, it was a huge lift, and then from an operations perspective, it's a giant pain in the butt, but it was necessary, right? It's the necessary evil of the video internet today. So we were able to build some pretty cool stuff on top of that from a traffic management perspective. And what I call traffic management is simply moving stuff around in real time, right? So we have a few puppet masters in the network that pull strings and make Pinocchio dance in certain ways, depending on what's going on. So we have these macro environment issues, data centers losing power, networks having a massive outage, transit providers having subsea cable cuts, things like that. And then we have these micro issues. That might be just a really large file is trying to get through the system and clogging things up, or burning cache footprint, and we're going from a 45-day retention to a 4-day retention. We're like, what's going on, right? So there's all these different occurrences that we have to detect, and basically it just generates way too much data. And then we have to act on that data and sift out bad data and false data and red herrings, and then we have to act on that data. And by acting on that data, we can either keep things the same, make things better, or make things a ton worse. There's no in between. And so we have to measure what those changes actually do to the network, and then that generates more data, which then has to kind of go back into that virtuous cycle. So we said, look, we can't have people doing this. This is just ridiculous, and we couldn't scale. We'd have to have hundreds of these people sifting through this stuff. So we automated a lot of it. We have this tradition of calling everything after fish. So Sailfish is our caching proxy service. It's the fastest fish in the sea, which is why we call it Sailfish, because we have fast caching. So we called this Heteractus. Bonus points if anybody knows what a Heteractus is. And then the system that does the change management on top of that is called Clownfish. Any Finding Nemo fans? So clownfish can live in a Heteractus. That's the sea anemone that's poisonous to others. So they work well together, symbiotic relationship, et cetera. So Heteractus basically is the foundational system that takes all this data in and then generates changes. So in the end, the machines will win is my mantra, and they just do all the recommendations. And then based upon how risky those changes are, we'll either automatically implement them fully, just like, okay, go, this is super safe, do it. We've done it millions of times. Or we might say, okay, this is a little risky. We're going to A/B test this. Or a few lucky customers are going to get this before the rest. Or we're going to canary this, one server, 2 servers, 100 servers at a time until it's rolled out. Or one network provider, and then 10, and then 100, and then 1,000. Or 2 POPs, and then 40, et cetera. Or it might actually need human intervention. It's so risky that we want to take a look at it. We want to call up the on-call guy at 3 o'clock in the morning and say, okay, you're a professional, take a look at this. What do you think? This is what the system is recommending. And then the system obviously gets smarter based upon defect rates of those changes. So we try to get the change management system up to about 99.8 some odd percent effective, which means that the automated system is making a goof, 0.18, 0.17 times, which is pretty good for the internet, right? Which is kind of a best effort service I've heard. And then if you think about a live event, we did over 42,000 live events last year alone. We're going to do over 65,000 this year. It's just crazy. And there's only 365 days in the year. And a lot of times the customers have the nerve not to even call us and tell us that they're going to have this super popular game download or super popular live stream or super popular sports game. Indian tag. I don't know if anybody's ever played Indian tag. That is an awesome sport, and it actually generates a ton of traffic. And their schedule is erratic, and it changes all the time based upon the cricket schedules, et cetera, because they don't want to compete with that. So we see all the sports and software, and the customers don't really coordinate with each other. So they don't really care that a major television broadcast is happening. They're going to go forward with their sporting event. But we have to manage that. So based upon the traffic levels, as circuits start to heat up, we start to make more and more changes. And those changes they go from scalpels to hatchets, right, in terms of the level of granularity and coarseness. We never want to see that happen, obviously, so then that generates capacity planning information so we can prevent that from happening again. And ultimately, it generates network architecture changes for the future POPs. But the goal here is really to be proactive, right? It's to make a change in the network and have the confidence that that change, that software-defined change on that network, which is basically just infrastructure as code at that point, to make that change proactively before the customers ever feel it. If we're doing something reactively, it means we've already got, some consumer out there is not happy about something, and we've definitely failed. And the second goal is to be progressive about it. So to constantly get better and better and better, and to use those changes on top of that new architecture to ultimately scale up without having to do that. I'd love to get to 100% where that header actus bot is making more and more changes without human intervention at a wonderful success rate, but I think that's an unfair and unrealistic goal in this kind of environment. So I will wrap up and take some questions. Basically, what we decided to do here was to go crazy with doubling up every single time. To do that, you got to put a lot of heavy iron in the ground, but then you also have to treat that iron as a slave and tell it what to do in an automated, completely mechanical fashion to where it's blind. So we've taken a lot of that intelligence out of the heavy iron and put it in the software layer and just treated that infrastructure as a piece of code where we're making dozens or even hundreds of changes on that code base in a day, right? Very similar to what we do on the safe, Scrum Agile side for our overall, operating stack. It's the same thing that we've done to the network layer. To do that is super important to get redundancy and reliability for customers, and to focus on those mobile-first countries where you have to completely redesign your architecture and rethink it, and experiment and fail, and work with the local partners to kind of adapt and evolve beyond just doing the same thing over and over again, which there's nothing more that I love in an operations role than doing the same thing over and over again. But unfortunately, our customers don't really like that. And then lastly, the network's got to get smarter as it grows. So you have to use that data and machine learning on top of that to ultimately have the network be smarter than you, right? So our header actus system is smarter than any of my traffic management engineers, any of my data scientists, any of our architects, because it's the sum of all of their parts, right? At a certain point, I imagine it'll just completely run our network, and it'll be doing this presentation in a few years. But for now, you're stuck with me. So I'll take some questions. I'm sure there's lots. Yeah, go ahead.
Just one simple question. So 3,000 interconnects has been steady. Is that just a fact of life?
I don't want to change it till I hit 4,001, but it is going up. So his question was around 3,000 interconnects being steady. 2.5 years ago, it was about 1,000. About 18 months or so, year and a half, it was over 2,000. Yeah, maybe you're right. Maybe that's a typo. I'm not really sure. But we have added a massive amount. What we call interconnects are unique networks that we are directly connected to. So like, just because I add another port with Comcast, that doesn't give me another interconnect. You know, it's got to be a unique new network. But to your point, there's only so many autonomous system networks out there that actually consume traffic on the internet, right? A lot of private ASs, but the number is still growing. I'm going to guess we're going to eclipse the 4,000 number this year, but at a certain point, that will plateau. Yeah, go ahead.
You dynamically load balance viewers from one edge to another edge, and with that, don't you have to keep the content like within 100 milliseconds or so of each group of players?
Yeah, so he's asking about dynamically load balancing consumers basically across the edge, and will that really screw things up, especially if you move them further away? And what does that do to, maybe you didn't ask it, but I'll add to the question, what does that do to cache pollution, right? Because now you're asking for the same asset in a different location than you were in that original location. So the answer is yes, we absolutely do that. Do we want to? No, we obviously want to let Anycast be Anycast. We run a complete Anycast network. There's very little, I'll say basic DNS resolution. If you look at our, performance stats, we squeeze a massive amount of latency out of the DNS resolution time by running Anycast. And ideally, we want the consumer to be served where that request came in, which is the definition of Anycast. Wherever that request comes in, I will return it there. It's really that simple. But sometimes that's not always the case. If that request comes in, because the request is teeny tiny, right? And then the payload, i.e. the video or the file or the game or the image or whatever is much larger. So sometimes that's not always the best path. And sometimes we may see, well, there's massive congestion on this downstream network here, and they're even letting us know by dynamically changing their meds or by sending us a beacon or whatever that we've worked out with that partner. So the best route is actually the longer path. 100 milliseconds, we would never try to go that crazy, but I get your point. It's a valid question. We don't want to, and if we do that, we'll do that for a couple of them and see how it goes. And if it's good or better, then we'll go that route. But we're not going to try to make a fell swoop and say, okay, we see 1 or 2 minor problems here. Let's start serving Comcast, instead of from Chicago. Let's go to Denver. Like that, that's going to really hurt consumer performance unless Comcast has got some major problem in Chicago. Definitely not an ideal situation, but it happens all the time. The cool part is when we can dynamically do that for different types of content first, right? So we have non-performance sensitive content on the internet. If you think about what's happening right now to your Xbox at home, it's probably getting updated late at night or something like that, and you don't even know. Versus Christmas morning when you give a gift to your son or daughter and they go and download that game right away. They want that game to load fast, but the update that's getting pushed, it's not that performance sensitive. If it takes 10 minutes versus 2 minutes, nobody's going to be none the wiser. So we can detect what customers have the most performance sensitivity and take actions to ensure their performance over others. And no, I'm not saying prioritization on the internet, definitely not. Talking about net neutrality, as I do work for Verizon. But when you're making automated traffic management decisions, things like that come into play. Yeah, go ahead.
Yes, thanks. Can you talk about what kind of applications or functions or content are going to go into those 50,000 next? Or I guess that's another way of asking, where did the 50,000 come from?
Yeah, sure. So MEC is the MEC is the acronym that everybody likes to say, and nobody really knows what it means. And I would say that, some people look at our network map and they're like, oh my God, you only have 125 pops. That is so lame, right? And it's like, look, it's not the number of pops, it's how you use them. I'm sure there's a bad joke there somewhere, but the concept that MEC is pitching is, look, you need to be sub 5 millisecond latency for IoT and for alternative reality and virtual reality streams and things like that. So you can't be in an Equinix carrier neutral facility. You have to be at the cell towers, right? Excuse me. And there's lots of cell towers, right? American Tower, Crown Castle, et cetera. I mean, there's probably 10,000 just in the States alone. If you think about worldwide, that number is massive. So everybody's trying to figure out their MEC strategy and how that plays in nicely with 5G. For us, we have big application around e-commerce and application delivery, IoT, and AR/VR. Those would be like the main 4 MEC use cases for us that we would play in from a CDN. So then you have to think about how to containerize your platform, how to run more serverless applications, how to go from this massive football field-sized data center to a data center as big as a couple of these tables stuck together. And that has significant ramifications, right? When you think about caching is basically just a fancy way of saying storage. And storage takes up space. And you want to have good caching by storing all the content and keeping it there locally rather than having to go call back to origin or some origin shield or midgress location and grab it again, because then that's adding a round trip, right? The trombone, the hairpin. So we want to keep content as local as possible. So then you have to start thinking a lot smarter about what content you store there. And taking a TTL from a customer is great, but sometimes you got to just completely ignore that and start doing things like predictive caching and proactive caching and be like, oh my God, it's getting hot over here in Western Pennsylvania. I'm going to go ahead and start populating this asset elsewhere to reduce that time to live or click to flick or whatever metric you want to call it, time to first byte. So it's a big question mark for a lot of people, and I guarantee, MEC Summit or whatever we're going to rename this thing, it's coming. It's a challenge for sure. Yeah, go ahead.
Can you talk about how your CDN is different from some of your competitors?
It's better. So yes, how is it different? So if you look at their network slides, they're going to have thousands of pops, right? And we don't have number of pop envy there. We look at performance traits. And I think I'm getting the hook soon. So it's not the number of pops that you have, but it's what's in those pops in terms of how much streaming capacity can you satisfy, what your cache hit ratio is, and how much storage can you actually have there, so you don't have to keep slamming somebody's origin, right? I can have 20,000 little tiny pops in some telco's basement locker. But if I have to keep going back to origin for that content over again because I don't have enough storage and throughput capacity, then what's the point of even having the pop? You might as well just serve from origin. So we really like to differentiate ourselves on the software around caching and traffic management and make sure that our cache hit ratio is in the high 99%. So we're barely touching the origin, we're keeping that content local, and we're serving it with really good quality there. I bid you adieu.